Right now, our planet is shouting into the dark. Down there, streetlights, television broadcasts, and radar pings are bleeding out into the surrounding vacuum. If you move away from that glow, past our own sun, and out to the edges of the Milky Way, the scale of our neighborhood begins shifting. Within our galaxy alone, there are an estimated 100 to 400 billion distinct stars. Many of them are billions of years older than our own. This diagram looks beyond the Milky Way. Multiplying that star count by the 2 trillion galaxies in the observable universe, and factoring in the probability of rocky orbiting planets, the math yields a staggering volume of worlds. Even if basic biology develops on only a tiny fraction of those planets, and an even smaller fraction builds advanced technology, the sheer scale of the numbers dictates that we should see civilizations everywhere. According to the raw statistics, the universe is built to be crowded. A completely empty cosmos defies the laws of probability. Yet, despite all that mathematical certainty, we have found absolutely nothing. In 1950, physicist Enrico Fermi looked at this direct contradiction between the high probability of alien life and the total lack of physical evidence, and formalized it into a simple question: where is everybody? We have spent decades actively sweeping the skies for an answer, building massive arrays to scan the vacuum for rogue radio waves or deliberate communication. These massive instruments have spent half a century listening to the background static of space, returning 0 messages, 0 signs of megastructures, and 0 evidence of anyone else. Our physical reality is clashing directly with our astronomical models. The math guarantees they are there. Our eyes and ears report we are entirely alone. To resolve this paradox, we have to look at the variables in the equation. The first possibility is that the math is perfectly fine, but we are just incredibly early. This diagram shows the 13.8 billion year history of the cosmos. Heavy elements formed, our solar system coalesced, and human intelligence emerged right at the final sliver. Looking forward, the universe has trillions of years left. On a cosmic scale, the environment has just stabilized. Millions of other planets are likely hosting basic biological processes that are still slowly evolving, millions of years away from inventing the wheel, let alone a radio transmitter. We might not be late to a thriving galaxy. We might bear the solitary responsibility of being the first generation of advanced intelligence to wake up and look around. In this scenario, the paradox is resolved by patience. The silence represents a waiting room for a crowded future that hasn't happened yet. But there is a second, much darker variable to consider. What if the probability of planets is correct, but the likelihood of a species surviving to leave its homeworld is critically flawed? This diagram outlines a concept known as the Great Filter. It represents an inevitable evolutionary or technological barrier that blocks civilizations from ever expanding beyond their home star. This filter could be completely natural. A civilization might always exhaust its planet's resources or suffer unavoidable environmental collapse before it can build starships. Or the filter could be self-inflicted. The very technology required to harness planetary energy might always provide the means for rapid, uncontrollable self-destruction. A capable civilization could strip away its own atmosphere or trigger a biological cascade, leaving nothing behind but an irradiated rock floating in the dark. If the Great Filter lies ahead of us, then the lack of signals isn't proof of an empty universe. It is the grim echo of a cosmic graveyard, filled with species that reached this exact technological stage and failed the test. The final variable assumes life is out there, but our own observational tools are completely inadequate to detect it. We measure our attempts to communicate by sending primitive deep space probes, slowly drifting out into the physical dark. We attach maps and etchings of our biology onto metal plates, hoping someone stumbles across them. A civilization with millions of years of evolution wouldn't use radio waves or metal plates. They might communicate through neutrino bursts, or gravity waves, or quantum entanglement. Signals our current instruments literally cannot see. Our perceived isolation might simply be an illusion caused by a massive technological blind spot, keeping us deaf to a galaxy that is actively communicating right past us. For now, the search remains bound to human beings sitting in rooms just like this one, looking at the data, waiting for a blip on a screen. We have tested the mathematical variables and hypothesized the great filters, but the equation remains unbroken, and the sky remains completely silent. Whether we're the first to arrive, destined to face a deadly hurdle, or surrounded by unseen observers, the immediate stakes are exactly the same. We have to navigate our own survival first. The Fermi paradox ultimately acts as a mirror. The true significance of this search lies in what humanity achieves during its own long era of solitude.